Alright everyone, welcome back to the day 39 of our daily leetcode challenge, and today we have got design a number container system. So let's try to understand the problem. In this given question they have provided us with a list of operations that they're going to do, and there are two kinds of operation. First is either an insert or a replace, and the second one is a return. So let's try to understand each of these. In an insert or replace operation in the container, which will look something like this, they will be in the pair of I and j. All the insert or replace operation will be in the pairs of I and j, meaning the ith value will be the index and the jth value will be the value. Meaning in this container you need to insert the value 10 at index 2. This is what it means. This means that you need to insert the value 10 at index 1. This here means insert the value 10 at index 3. This here means insert the value 10 at index 5. And this right here means that you have to replace now whatever value you had at the previous index, which was 10, with a value 20. So if we ever encounter an index that we have previously inserted or previously inserted a value at, we need to replace that with this new value. So this 10 will get replaced with 20. So that's that. This is how the insert or replace operation is working. The other one is where we need to return something for a given value. So what that something is, we need to return the smallest index at which this value is present. So if you take a look at this example, you see we have got 10 coming at index 2, index 1, index 3, index 5, and then again at this one, since 20 is replacing 1 at index 10. So if you take a look at 10 as a number, right, let's try to create a hash map for 10. With each iteration, what we are going to do is we're going to store at whatever indexes this value 10 appeared. So while we are iterating, we see 10 appeared at index 2, 10 appeared at index 1, then 10 appeared at index 3, then 10 appeared at index 5. That's all. But while we inserted the value 20, we saw that we kind of replaced this 20 that we have here, this 10 that we have at index 1 getting replaced by 20 at index 1. So now after this gets inserted, 10 is no more at index 1, so this needs to be removed from here. So this will look something like this after all the iterations are done: 2, 3 and 5. Now every time we need to see where a 10 is, what we need to return is, we need to return the smallest index at which 10 is. So when we first kind of encounter 10, we see that 10 has not been inserted yet, so we return a -1 since it's not there. The second time when we ask 10 is at this place, and when we reach here, we see that 10 has been inserted at 1, 2, 3, 4 indexes so far. So the moment we reach at this point right here in the iteration, our map, or you could say the map for 10, will look something like this: values like 2, 1, 3 and 5. Out of these values we need to return the smallest index at which 10 is, which is 1. So that is why in this case 1 was returned. If you see in this example, 1 is returned. The first value is 1 getting returned. Now when we move here, when we reach up till here, we see that 20 is getting added at index 1. So this means that 10 is no longer at index 1. So this 20 basically is removing 10 from index 1. So this one needs to be removed from this list. So now our list becomes looking like this: 2, 3, 5, and 20 now has index 1 in it. Or you could say at index 1 now we have a 20 instead of a 10. So that is why this 1 got removed from here and added in the place of 20. Now once we reach here, we will see that what is the smallest index at which 10 is present. So it's 2, that is why we are getting a 2 here. So this is how what the problem is. This is how the algorithm, this is what they want us to do. So now let's try to see how we can do algorithmically this problem, how we can solve using algorithms. So again, like if you see, we discussed that we created a map to check which number is at which index. So let me propose you a solution for this, and in this one we're going to use 2 hash map. So they're going to be 2 hash map. First hash map will be to kind of store which index has which value in it, because if you see just now in one of the examples we saw that in this case 110 and 120, we knew that at index 1 10 is residing, but later when we came here, which is 1, 20, we had to replace this 10 with a 1 to 20. So how will we know that 1 has been mapped to 10? Just like we use a similar concept in the previous problem as well, which is the number of distinct colors. Whenever we have to make sure that we need to check if this value right here has been mapped to a previous value which we are currently at, which we are currently at, has this one been mapped to someone else, we'll need to use a different hash map for that. So they're going to be two hash map. First hash map is going to be for which index has which value on it after each iteration. Let's say further down the line we came up with something like this. 1 is getting mapped to 10, so we add that to the hash map. 2 is getting at index 2 we have a value 5, so we add that. 2 is getting added to 2 gets getting mapped to 5. At index 2 we have a 5, and then let's say we have a 3 which is at index say 7, so we add that in the hash map. 3 is at index 7. So what I mean is we'll basically need two hash map for this problem. What are those two hash map? First hash map will be to find which index has which value, that is first hash map, and the second hash map is a value is present at what all indexes. Each value is present at what all indexes. These are the two hash maps that we're going to need. So the first hash map is going to be an index, let's say I has what value on it currently. This can get updated later and it will be useful for us, because if you see in this case 1, 10 and 1, 20, let's try to do a quick dry run on these examples. So every time we encounter this one, this would mean we are mapping something. So here it says at index 2 we have a 10, so let's add that. At index 2 I have 10, and this also means that at 10, that this value 10 is appearing at index 2. So for this value 10, imagine for this hash map we have a list, which this list has all the, you could say this list basically has all the indexes at which a particular value is appearing. So if we do that, when we come at the first iteration, which is this one, these are basically everywhere we are either doing a adding or replacing. This is what gonna help us build the two hash maps, and these are all the queries which we'll deal with them later. So initially we put value 10 at index 2, so this is what it shows. At index 2 I have put the value 10 and this here means that the value 10 is present at index 2 as of now. There could be further more which we'll be seeing here, but then as of now the value 10 is present at index 2. Now let's move further. We see at index 1 we have to put a 10, so let me add that. Index 1 I have to add a value 10, so I added that. And this also means that this value 10 is present at not only at index 2, it is also present at index 1, so we need to add that to this list as well. So we added that. So now we added that, so we have 2 and 1 as of now. Now comes the other value, which is 1, 10. So this means 3, 10. We have to add 10 at index 3. So I'm adding 10 at index 3. So this also means that this value 10 right here is also present at index 3. Not only 2, not only 1, but also at 3. Then we came at a value 5, 10. 5, 10. So we have to put index 5 corresponding to 10. So this means that we have a value 10 at index 5, and also meaning that this 10 is appearing also at index 5. These are the two hash maps we are updating simultaneously. This will help us in getting some answers that I'm going to discuss later. So far let me build the hash map. So 5, 10 is done. Now comes 1, 20. So what I mean by that is, if you see 1, 20 is going to come in this hash map now, but we see 1 is already occupied with a 10. So this will get updated here, right? This one we have to put 1 at index 1, we have to put a 20, but we see that 1 at index 1 we have already put a 10. So this 10 has to be removed. But if you take a closer look, you see that we are removing this 10 from this index, right? We are removing this 10 from this index, but we'll also have to update this list, right, that we are currently. So since we found that this value 1, that index 1 that we are trying to put 20 at, 1 is already present in this hash map. This hash map 1 is already present in this hash map. This means that we already have a value which is present at index 1, which is true. We have a 10 here. Now since we need to put 20 now at place of 1, this 1 needs to be removed from here in this places where all the indexes where all we find a 10 at, this needs to be removed. Like this 1 has to be removed from this. So before we update a 20 here, we need to remove this from this list. So now only 2, 3, 5 appears here, and this 1 gets updated to a 20. So this means that now previously we had 10 at index 1, this gets replaced with a 20. So that's one. And the other thing that we also have to make sure is all the indexes at which 10 was appearing, we have to make sure that we remove 1 from it now, because at 1 we now have a 20, so we have to update this as well. So now for 20 we have 1. So have you got this? Because this is how we are updating the hash map. That is why whenever we are checking, the value 10 now appears at what all indexes. In this case the answer is 2 because 1 got removed. Now let's take a look at the query part. So every time we have a single value, this means we are looking at a query. We need to find that for the value 10 or for the value x, which would be in this hash map, all these values, that could be 10 here, 20 here, it doesn't matter. Out for all these values, whatever indexes that we have, like whatever indexes this particular value which we are querying is present at, you need to return the smallest value. So in this case, before 20 pushed 10 before 20 kind of pushed 10 out of index 1, before this happened, 1 was part of the list. So in that case, when we reached here, we had returned 1 because 1 is the smallest index at which 10 is. But once this operation happened, 1 comma 20, we replaced 10 from index 1, we removed 10 from index 1 and put a 20 on it. So that would also mean that you have to kind of update this list right here. 1 gets removed now. So at this point, when the second query runs, which is 10 right here, we are trying to see what is the smallest index at which 10 is present. So that will be 2 now, not 1, because 1 has been removed and has been moved from here to this one. So this is how the iteration is happening. This is where the 2 hash map is gonna help us. So that's one. This is where the 2 hash map is coming. And now if you see this hash map, right, this hash map, in the places of values we are having a list, and in this list we are adding all the indexes at which this particular value is appearing. So this means that this value 10 initially, when this operation happened, before this operation happened, the value of the value for 10 in the hash map looks something like this: 2, 1, 3, 5. We are storing all the indexes at which 10 appeared, which it was 2, 1, 3, 5. Every time we are querying, right, we need to return the smallest index that at which 10 happens, or at which 10 is appearing basically. So if there is an efficient way to do this, it would be helpful for us. Otherwise, having to find the minimum in all of these values would be kind of like a expensive operation. So what if I say that there's a way to insert values already in this list in a sorted manner? Like if we already define this list as a sorted list in Python, there's a way to do this. What I will do is, instead of defining an empty list as a value for each of these keys, I'm going to define a sorted list by default for each of these keys that you see here. So when that happens, whenever we will be adding values in this sorted list, right, which will be 2, 1, 3, 5, by default we will always keep them as sorted. It will always keep them as sorted. No matter whenever you add it, it will always keep them as sorted. So that is why whenever we will be querying it, we can only return the value at index 0. At index 0, we will always have to remove. We'll always have to return. So that is why when this 1 gets removed after this operation right here, the value at the 0th index will now be 2. So that is why 2 gets returned here. So this is how the hash map is going to be built. First hash map is going to be a simple one, which will be which index has which value. At index x, I have value y. This will be the first hash map. And the second hash map will be which value is present at what all indexes. The values, all those indexes at which a particular value is stored is, we'll have to store that in a sorted list. I'll be defining a sorted list in the instead of the key, like this is the key and this is the value for the hash map. The value is the list itself, and this list is not a normal list. This is a sorted list. So we'll define all that in Python. You'll see how we code this up in Python, and let's try to do that now. So this init method that you see here is where we're going to define everything that we are going to use. So first is that we need a hash map, which will be a normal hash map, which will store which index has which value. That's one. And the other hash map will be like what values are at which or what indexes a particular value is. So to define such an index where the key that we discussed here, a key is corresponding to a value, and that value is nothing but a list. So that can be done in Python using this method called default dict. Default dict right here. So this will help us to make a list as our value. Instead, for each key, the value will be a sorted list. So that can be done using this lambda function. So what this basically means is I'm trying to create a hash map in which for each key I'm getting a sorted list as the value by default. Initially this will be empty, right? This will be empty initially, and this hash map is nothing but to get which value is present at which index. Like index 2 we have value 10, at index 1 we have value 10, so that when later down the line when we will be coming here, which is 1 comma 20, we'll get to know if this one that we see here is present in hash map 1. If this one is present in hash map 1, that would mean that this one is already being mapped to a value before. So we need to get that value, and in that value we need to have to remove that index which is 1, and that's it. And so that we always get the current count of indexes that is presently at there for that particular value that we saw here in this one. With that removal part we did. So this is what we have here. So this is index and number. So first we need to do a check if this index that we just are at, if index in self dot hash map 1, because this will become true in this case 1 comma 20. This index 1 is already present in this hash map, right? It's present there, and so and since it is present, we need to get the previous number. Previous number will be nothing but this index. This is the previous number for at which this is the previous number which was currently mapped to this index, right? Now what we need to do is get that list, get that longer list that we discussed here. We got the previous number in this case. In the case of, if you take a look here, 1 comma 20, right? 1 comma 20 here appeared. So when 1 comma 20 appeared here, we saw that this index this index 1 is currently in that self hash map 1, meaning 1 at index 1 we have a 20 in the first hash map. When we reach here, we saw that this index 1 is already there in the hash map, meaning a number is already mapped. We need to get that number. We can get that number by calling this value in this hash map. We get 10. So now we have 10. Now what we need to do is look at this list that we have here, get all the indexes at which 10 is present, and remove this one from this hash map, this list right here, so that this will always return us with the correct answer and not the wrong answer. Otherwise we have to kind of make that update, remove this one from here and later update this one for the value 20. So this is what we're going to do now. So the list that we'll be getting, right, will be from this hash map 2, and from this list we'll have to remove that index. So that can be done using this. This ray right here is the list that we discussed, this bigger list which has all the indexes, and in this and from this list we need to remove this index that we just have, because now this index is getting mapped to a new value. This would mean that the previous value no longer has this index, right? So we need to remove that, remove this index. So that is done. This is where the removal part is done, and now since that is done, we need to do our normal part, meaning we have to update this hash map with what index. This index is at this number, this index has this number mapped to it. So that can be done using self dot hash map 1. This index is getting mapped to this number, right? This is what hash map 1 is. When the hash map is initially empty, this if block will not run. This will only run because 1 comma 10 was mapped before. Only then 1 comma 20 went to this loop right here, because 1 comma 10 was mapped there. So that's that. And in the other one, which is for this particular number right here, map 2, this number, for this number we have a sorted list already defined that we discussed here. For this number, in the first example, 2 comma 10 it will go in this one. 2 gets mapped to 10, and for 10 we have a sorted list, and in this sorted list we need to add this index 2. So that will be done using the add, not append. You have to make a note of that. This will be a add method, not an append method, because this is a sorted list. So this is where the insertion is happening, or all those insertions are happening which are like these, all those insertions and removal as well, so that we don't get wrong answers. So when that is done, now let's try to see the query part. For the query part, let's say that we are trying to find, now this is the query part, and then the query part we only be taking a look at this second hash map. So initially when we didn't insert any value, the hash map 2 is basically empty, and we're trying to query a number. So if the hash map 2 is empty, or if for a particular value, if it's there in hash map, let's say 5 is there in the hash map, we are trying to query 5 is present in the hash map, but for that the list that we have is 0. the length of that list is 0. In both these cases, we're going to have to return a -1, meaning that first the number has not been pushed yet, or it has been pushed, but the length of that particular list is 0 because of some removal that happened before. If that happens, that in that case, for that particular number, even though if it's there in the hash map 2, the length of that list will be 0. So these are the two conditions in which for hash map 2 we're going to return a -1. So if number is not in self dot hash map 2, or if the number is there in the hash map 2, right, but the length of the list that we are getting for that number is equal to 0. In both these cases, we'll have to return a -1, and if that's not the case, we'll simply return whatever list that we get for that, whatever list that we are getting, which is this list that we are getting, right, this list that we are getting. At this list, we need to just return the value at the 0th index, because this is a sorted list that we have defined. This is a sorted list. Every time we add or remove number, the order will be always be in a sorted order, will be smallest to greatest, ascending order will be sorted. So we can simply return the 0th index. Even though this one got popped, the smallest number will still be 2. The order will be maintained. So in that case, the 0th index will be 2. So we just return the 0th index. So I hope you are getting it. Now let's try to run all the test cases that we have here. So as you can see, it's satisfying all the test cases. Now let's try to submit this. So as you can see, it's satisfying all the test cases, and so that was it for today everyone. I'll see you in the next one. Like and subscribe. Bye.